Section D, Chapter 1, Finding a quadratic equation given its graph. We're going to look at two different methods today. The first method is when we're given the x-intercepts and we know one additional point on the graph. So step 1, we need to identify our P and Q from the graph. Now recall from our previous section, P and Q are the x-intercepts. Then we're going to use the additional point identified. Then we're going to plug it into our intercept form of the equation. So in this method, use the intercept form of the equation. We're going to, after we plug in P, Q, and the additional point in place of x and y, we're going to solve for A. And then we're going to go back to our intercept form of the equation, plugging in only A, P, and Q. So let's look at our first example. Here in example A, we're given a graph. And we first identify P and then Q. So P is -1, Q is 3. Step 2, we're going to identify another point somewhere on our graph. We need a very distinct point on the graph. And we're going to label it as an order pair. So I have this y-intercept here at 3. So that would be the order pair 0, 3. Now, since I was given x-intercepts, I'm going to plug this into the intercept form of the equation. So recall, the intercept form of the equation is y equals a, parentheses, x minus p, close parentheses, times x minus q. So let's replace the p and the q. So in place of p, I'm going to plug in -1. And then in place of q, I'm going to plug in a 3. Alright, I know minus a -1 simplifies down to x plus 1, so let me write that down. Alright, step 2 says use the additional point, 0, 3, to identify, and then we're going to solve for A. So I'm going to plug in place of y, 3. In place of every x, 0. And then we're going to simplify this equation and solve for A, which is our step 4. So I get 3 is equal to A times 1 times -3. -3 times 1 times A is -3A. Then I'm going to divide each side by -3. My A here is -1, which makes sense. I have a negative A term, so I should be concave down. So now I'm going to go back to my original intercept form equation, plugging in A, P, and Q only. So recall, intercept form of the equation is y equals A times x minus P times x minus Q. Substituting in A, which is -1. And since it's a 1, all I have to do is write the negative. And then substitute in my P, which was -1, so that becomes a +1. And then substitute in my Q, which was 3, so I got x minus 3. And you have successfully found an equation of a quadratic from the graph alone. In example B, notice that we only have one x-intercept, which is 1. So recall when we were doing discriminant, when x is only one x-intercept is when we have a repeated root. So since P is 1, Q is also 1. This is a repeated root. And then my additional point is -3. So I'll write that as 0, -3. So I go to my intercept form of the equation, replacing P with 1 and replacing Q with 1. So y is equal to A times x minus 1 times x minus 1. Now I can rewrite this as A times x minus 1 quantity squared. Then I'm going to plug in my x of 0 and my y of -3. And then I'm going to solve this equation for A. And I find that A is equal to -3. Then I go back to my intercept form of the equation, plug in P, Q, and A. So A is -3, that's x minus 1 times x minus 1. So I would simplify that down to y equals -3, parentheses x minus 1 quantity squared. In our third example, we still have our intercepts, but this time they didn't identify our second intercept. All we know is we got one intercept at -2. Our second intercept is here, but we don't know the value. But they gave us something else. They gave us a hint to help us figure that out. They gave us the axis of symmetry. So I need to figure out how far the axis of symmetry is from that x-intercept I know. So that has a distance of 3. So I need to go a distance of 3 from my axis of symmetry to get to my second x-intercept in the other direction. So that means my second x-intercept must be 4. So P is -2 and Q is 4. Then I need to identify my one additional point. So they identify the y-intercept here of 16. So my additional point would be 0, 16. So since I know my x-intercepts, I'm going to use my intercept form of the equation. I'm going to replace P with -2, and I'm going to replace Q with 4. Let me write that where you can see it a little better. And then I'm going to use my additional point 0, 16, and I'm going to replace y with 16 and x with 0. So that gives us 16 is equal to a, parentheses, in place of that x, 0, plus 2, close parentheses, and then 0 minus 4, close parentheses. Let's simplify this down. 16 is equal to a times 2 times -4. 16 is equal to -8a. Divide each side by -8. A is equal to -2. So now I'm going to go back to my intercept form of the equation, plug in P, Q, and A. So y is equal to -2, parentheses x plus 2, and x minus 4. And you found the equation of this graph. The second method that we're going to look at for finding the equation given a graph is when you're given the vertex and one additional point. So step 1, you're going to identify your vertex, h, k, and one additional point. Then you're going to plug it into the vertex form of the quadratic equation. So when you give the vertex, plug it into the vertex form. After plugging in the vertex and the one additional point, we're going to solve for a. Then we're going to go back to the vertex form, plugging in a and vertex only. So let's look at our first example. Here we know our vertex is 3, -2. And so we're going to use our vertex form of the equation, which recall is this. So I'm going to replace my h with 3. And I'm going to replace my k with -2. Simplifying this down, we have y is equal to a, parentheses, x minus 3, close parentheses, squared minus 2. So next step is we need to plug in that one additional point. So let's find another point, which happens to be the y-intercept here of 16. So that point is the point 0, 16. So in place of y, I'm going to replace y with 16. And then I'm going to replace x with 0. And then I'm going to solve this equation for a, which is my step 3. So that gives us 16 is equal to a times -3 squared minus 2. So 16, -3 squared is 9, so that's 9a. We're going to add 2 to each side. So that gives us 18 is equal to 9a. I'm going to divide each side by 9, so 18 divided by 9 is 2. So I know my a is 2. So now I'm going to plug in my vertex and a back into my vertex form of the equation. So I'm going to look at my vertex form of the equation, replacing the a with 2. replacing the h with the h of my vertex, which was 3, and then replacing k with the k of my vertex, which was -2, or the y value of my vertex. So my quadratic equation for this picture would be y equals 2 parentheses x minus 3 quantity squared minus 2. And that's method 2 of finding the quadratic equation. So here's another example. Now here, notice I didn't label the vertex, but it's easy to see. Now the x-intercepts, I wouldn't use the intercept forms because it's in between numbers. I can't really notice that value. But the vertex is very obvious that that is the point 1, -3. So I have my vertex on this graph. And then I need to find one additional point. Well, the only other one I know for sure is this y-intercept is 0, -2. So I found my vertex and one additional point. So that means I'm going to use the vertex form of the equation. And I'm going to start by plugging in my x of my vertex in place of h. So that's going to be -1, h is 1. And then plus k, k is the y value of my vertex, which is -3. Simplifying that down, we get y equals a parentheses x minus 1 quantity squared minus 3. Then I'm going to take my one additional point and replace y with -2, x with 0 in this case. And then we're going to simplify this down and solve for the a. So -2 is equal to a times -1 squared minus 3. -1 squared is 1 times a is a. So adding 3 to each side gives a is equal to 1. So now I go back to my vertex form of the equation, substituting in a in the vertex. So again, replacing a with 1, replacing h with 1, replacing k with -3. So my equation is y equals parentheses x minus 1 quantity squared minus 3.